but with a focus on mocking. I want to hit some core problems that we often run into when it comes to using test-driven development. And I want to use an example to build along and find out how we can solve the problem. But let's first talk about some of the benefits of unit testing. And best time to ask a question or make a comment is when you have it, wave your hand, draw my attention. If I'm not responding to you, usually it means that you're not in my line of sight, even if I'm looking directly at you because I'm thinking about something else. So draw my attention, I'll be more than happy to respond to your questions or comments. So one of the reasons I really like unit testing, I'm sure you've had this problem. Have you ever noticed that your code does what you type and not what you mean? Have you seen the problem? It's very frustrating when that happens, right? And then you say, darn it, that's not what I meant, and then you change your code. And there's another problem. When you write code and everything seems to work just for a while, and a few weeks goes by, you have to make a change to your code, and you modify it, and then what happens? Well, a few days later, somebody reports that something that worked before doesn't seem to work anymore. Well, why does that happen? Well, that's because software is a nonlinear system. You change something here, and something over there ends up breaking. And it's very frustrating when that happens, right? And so one of the benefits of test-driven development is to really get that quick feedback cycle, that what used to work continues to work as we evolve and make change to the code. So there's really good reasons to write test and unit test and automated test. In fact, I would say one of the crises in our field is that we don't have enough automated testing. But unit testing is very easy if the code we are testing does not have any dependencies. So if the code you're writing is a pure computation, you can call that method, send the input it needs, make sure it gives you the right output, and you're done. So that was pretty easy. You can write automated testing on it fairly easily. But the problem is the real world is not just isolated code. We often have code which depends on other pieces of code. There may be a code that talks to a data in the database. There may be a code that talks to a remote service. There may be a code that talks to a system that's going to come back and give a notification to us at a later time. It gets really complicated. And what do we do in those times? We try to write test, and the test becomes rather unpredictable, and then it ends up failing quite often. And what do? We quietly say, well, you know what, we can't test this code. I'm sure you've heard this phrase, right? Sometimes people say, my code is not testable. And you know what that is called? There's something called euphemism. Euphemism is where you say a bad thing in a nice way. My code is not testable really means the design of my code sucks, right? And so if we design the software properly, every single line of code can be automated and tested, but how do we really get to it? And that's kind of what I want to address here today, is that unit testing is very hard when we have dependencies, but we can try to write, test around with a certain techniques that we can pick up and learn here. So this is where mock objects come in. So what are mock objects? Mock objects are objects that stand in for real objects. So rather than talking to the real object, why? Because the real object may be complex, the real object may be unpredictable, the real object may take time to respond, the real object may require a lot of setup to communicate to. Sometimes the real object is not even ready yet as we are developing the software, so what do? We instead talk to a mock object. And the mock object is an object that often stands in for a real good behavior. But also a mock object can stand in for ill behavior as well. How many times do you talk to an object, everything works fine, until one fateful morning, something went wrong on the server, it started throwing wrong results or error messages, and the application that you wrote quite didn't handle that, and everything breaks at that point. So what we want is a mock object not only to simulate behavior, we want a mock object to simulate ill behavior. So when such responses are sent back by the mock, our code says, I'm ready, I'm here to handle any failures that you may send towards me, and the code is ready for it. Now, I want to share with you a quick experience about this, how powerful this can be. You can say one of the things that you would probably do that is a bit serious is involving money, right? Because we're all sensitive to money. Well, okay, life is more important than money, At least it should be. But the point is, money is pretty sensitive. So imagine your application is going to charge credit cards. So here's what I did. I was on a flight, about a 2-hour flight from Denver to Minneapolis, and I wanted to implement this code to process credit card payments. So in the flight, I wrote this code completely automated and thoroughly unit tested. Obviously, I didn't have internet connection on the flight, so I was not, finishing integration testing at the point. So in a 2-hour flight, I had my code completely unit tested, and all my integration tests written up with, of course, ready to run. And as soon as I land, I'm a crazy guy, as soon as I land, I rush out of the airplane, find the first empty seat available. I'm sitting there for another hour in the airport because I'm eager to get this done. So I finish the integration test, and I'm sending in all kinds of input. One of the nice things is credit card companies give you all kinds of credit card numbers that you can use to test whether, poor, bad number, poor, wrong address, not available credit. All these things, they give you these test cases. So my code was fully automated, unit tested on flight, automated integration tested as soon as I landed, and everything is working. And I've never really processed a single credit card payment at this point. And call me crazy, call me stupid, but that gave me enough confidence. I pushed the application into production, and I've never charged a credit card. So what do? I called somebody who could really trust, and somebody who would not complain about things, also known as the wife. And I called my wife and said, sweetie, do me a favor. Could you please go to my application and be my first customer? And she's like, are you kidding me? You want me to pay for your service that I know I will not use? Like, please, can you do this? And then she's charging her credit card. I see the payment coming through, and it's like, yes, it works. And I said, give a wrong number, give all these details, right? So she's doing the manual testing for the one time in production, and the confidence, right, is because it was thoroughly automated, unit tested, and integration tested before deployment. And one of the things I want to emphasize is, I write automated tests not because I have a lot of time. I write automated tests because I don't have a lot of time. I'm extremely busy. I run around the world. I can never be sure where I am. And what I don't have the luxury for, that a lot of people do, is to spend the night debugging my code. I just don't have that luxury. I don't have the time available. So when I write code, I want to write code with quality, so I don't come back and keep fixing it and patching it. I just don't have that luxury to do. So that is why I believe in some of these techniques. So what are we going to do here? We're going to look at using these mock object of stand-in just to kind of distinguish between a stub and a mock. I won't go into too much of detail. I don't really care much about the differences most of the time. But technically, a stub is just a stand-in. You send a little information. It gives you back a fake response. That's all it does. A mock, on the other hand, will also tattletale. It will come back and say, well, let me tell you, this is the interaction I had. Here are the methods that were called. Here are the methods that didn't get called. So a stub is just something that returns a fake response. A mock kind of keeps track of the interaction and can tattletale. So depending on when you are interested, you could use a stub or a mock. Most of the time, I do two things. I use the word mock very loosely, even when I'm using stub. And most of the time, I actually use a stub and not a real mock itself. So to me, a mock is really, for the most part, in my vocabulary of communication, I kind of use the term very loosely. So given that, let's talk about, how the hell we talked about that. And we talked about good behavior and bad behavior. But I want to start with a little exercise and play with it. So let's get to this little example I want to start with, and then let's see how we can make use of this. So what I have here is I'm going to create a currency exchanger. And the problem given to us is we're going to be given a currency. I want to convert this to US dollars. And so you're going to give me, let's say, 100 rupees, and I want to get US dollars out of it. But this company that's going to do this job is going to do the following. It's going to talk to a service. And the service really entertains multiple vendors. So this company has deal with multiple vendors, and their business is actually to find the vendor that's willing to give the maximum exchange rate on that day, and then take a commission out of it and give you back the money. And their profit comes from that commission of a 2% commission, but for that they have to find a maximum profit by going to a vendor who's offering the best price. So it goes to the service, sends the vendor 1, gets a price back, sends the vendor 2, gets an error in this case, and then it can work with these different vendors. If there's an error, it logs the error because you want to know something went wrong. It could talk about to the service of vendor 3, that's giving the better rate. So it takes the better rate, marks it down by 2%, and returns vendor 3's price. So that's kind of what I want to really implement. But notice the problem here. The code I'm trying to test right now, rather designed right now, is the one in the yellow box. That's my code I want to build. The service is third party. I don't want to talk to the service right now. I want to just build my code. If I talk to a real service, my automated test will not work because the real service will be real and I don't know what value it's going to respond. How do you write a test that says the response must be this? So most of the time, what do people do? They say is greater than, is less than, is true, which are all kind of sad because you want the test to be fairly deterministic. You cannot say the value is greater than 0, right? It could be any garbage, you know what's happening. So how do you deal with it? So we're going to build this interactively and see how this is going to work. So let's give it a try. So the very first thing I want to do is I want to start with just a little warm-up, a canary test, which simply tells us that everything is still up and running and working. So I'm going to say over here, I'm going to call this as test canary, right? So we'll call it as canary. What is a canary test? It's a little stupid test which is going to simply say assert, and all that it does is true is going to be true. That's all it's going to do. And all I'm going to do is just run this one test and make sure that that one little test is actually passing. That will tell us that the system is running, things are set up properly for us to use, and all this good stuff, right? That's all we are doing right here. So notice I ran that little test, and it's telling me that the canary test is passing. Actually, there we go. So the canary test is passing. You can see that the test is passing. So that means the test tool is set up properly, and everything looks good. So that's all we saw so far. But I want to get to some real test. Now, the reason I start with the canary test is to make sure that everything is set up properly. So in case you are sitting on a new machine, and if something is not configured, it really gives you a handle to just focus on that problem rather than having a bunch of code you have written and then you're worried it's not really working, in this case just the tool. Let's go with the markdown real quick. I'm not going to go through a lot of details, but let's take a few example tests over here. So I'm going to test for the markdown here. And how do I test for the markdown? Well, I need a currency exchanger to begin with. So I'm going to go ahead and create a test initialize method. And I'm going to call this as an init method. And all I'm going to do here within the init method is say currency exchange equals. And I'm going to simply create here new currency exchange object that I'm going to use in this case. So this is going to be a currency exchange object. Where is that object coming from? Well, I'm going to go ahead and say that's going to be a field that I want to refer to. So in this case, the field, of course, is going to be right within the class. So I'm going to say currency exchange is going to be the currency exchange object that I'm going to use right here. So great, we have the object on our hand in the test initialize, and the test initialize is going to call it every time we run a test. And of course, for this, I need the library. So I have a library called the exchange library. I'm going to go ahead and bring that into the reference. All I'm doing here is I'm adding a reference to it right here, as you can see. And once I add the reference to it, we can bring in the reference. In this case, I'm going to bring in the exchange library. That's all I'm interested in. So that's what I brought in here. And then let's go ahead and say OK for that. So all we did was we brought in the library that we're going to use. So I'm going to go ahead and add a reference to it and say using that. Great. Now that I have the library on my hand, I'm going to simply say here a little profit margin, right? So assert R equal, and I'm going to say 98. And let's go ahead and say currency exchange. And I call the markdown method, and I'm going to send 100 to it. And this is going to be the markdown method. Well, that method doesn't exist. We're going to just go ahead and create that method. We just did. So let's go ahead and look at the method we just created. Well, that method says I'm going to return an object. Well, not really. I want a double to be returned from this. And I want this to be taking a double value. We'll say amount is the input we're going to say. And what do I want to do? Well, in a true test-driven development, you have to write minimum code. So I would be returning a 98. I'm going to violate from that principle here just for the sake of time here to move forward to the more important things. So I'm going to simply return the amount that's been given to us times 0.98. And that's all I have done so far. and I'm going to go ahead and run that test to make sure everything is set up properly and it's working. So we just wrote one other test, which is for the markdown, and the test is passing. I can see the result coming through, so we did. But we're going to get into the real part, which is to talk to the service, and I want to take very small steps. I'm going to take a step where I don't have any vendors today. For whatever reason, a configuration problem, what have you, or I'm just starting out, there's no vendors. How do I do this? So let's get to the test first of all. So what is my test going to be right now? Well, the test is going to be, let's create a test again, and this is going to be get rate when no vendors, right? I don't have any vendors, what should I do? Well, let's think about this. I'm going to say expected result equals, and I create very small tests, and the reason I do this is that I want my first few, supposedly a set of trivial tests to really help me define the interface of my methods. And I want the later test that I write to start defining the guts of the method. So I entertain the first few tests because I want those tests to focus, let me focus on, hey, what should this method take as a parameter? What should it return? And I'm not so interested in the implementation details of the method at this point. Once I write this initial test and get a handle on the input parameters this method is going to take and what it's going to return, then I can use a later few tests to focus on the internal of the method. So in other words, the way I write and develop tests is some initial tests help form the skin of the methods, and the later methods really help me to form the guts of the method itself. So that's kind of the way I want to approach creating this. So in this case, given this, what we're going to do here is I'm going to simply say this is going to be a new tuple, and it's going to be a string and a double as a result. And I want this to be a no vendor and no price because we don't really have any vendors. So I'm going to say assert or equal, and this is going to be expected result in this case. And this is going to return expected result. And where is this going to come from? Well, from the currency exchange, we'll say get rate for, let's say, an INR. And we're just going to give one value and get the value, some denomination, and get the value. Well, the get rate doesn't exist still, so we're going to go ahead and implement the get rate method. So right there I said go ahead and implement it. Let's go visit the method it wrote, and you can see that the method it wrote is returning an object again, and I'm going to change that to returning a tuple because that's what we defined over here, which is a string and a double. And the get rate method is taking a string as an argument, and the string that it's going to take as an argument, I want that to be the currency that we're going to pass to it. And what do we want to return from this method? Well, I'm going to simply say return new tuple, and this is going to be a string and a double, and all this is going to return is an empty vendor and a 0.0. Well, while that's running it, let's talk about whether that's a good idea. Well, obviously, if you're going to go to a service and give your money, and if they say, thanks for giving the money, we're going to give back nothing, you're going to say thanks, no thanks, and walk away. So if the system is not working, that's probably a safe result to give to a user, and the user is going to say, thanks, this service is broken today, I'm not going to use it. So the test is passing, so that seems to be working fine, but now I'm interested in having one vendor. So how do I talk to one vendor? Let's go ahead and write the test for it one more time. So this time, I'm going to go ahead and say that the test I'm going to write here is going to be get rate with one vendor, right? So I'm slowly building into it. So what is this going to be? Well, this is going to be an expected result. I'm going to quickly take stuff from here and use it. So this is going to be an expected result, but the expected result I want to pass here is going to be a vendor. So let's call this as vendor 1. And the value is going to be 98 from this. So I want to say expected result is going to be this. But if you look at the test, we never told what the vendor really is. That needs to be given to the currency exchange. So what I'm going to do in this test is I'm going to say at this point that the currency exchange dot, let's call it as a set vendor, and this is going to be a vendor 1 that I want to pass to it. So that requires a bit of work on our part to make this work. So what am I going to do? I'm going to go to the class first of all. Well, actually, let's go ahead and implement this set vendor method while we are here. So I'm going to just go ahead and click over here to say, go ahead and implement that method for me. It just did. And if we go back and visit this, it created a set vendor. I'm going to change this to a vendor. We'll call it as the vendor for now. And what am I going to do within this method? All I'm going to do here is simply say vendor equals, and I will say the vendors. And then, of course, the vendor needs to be defined. Let's go ahead and define that as a field within the class. So you can see it said string vendor and implemented. So we're ready to implement the code to get this work done. So what am I going to do within the getRate method? Well, I'm going to simply say for now, if the vendor is not equal to a null value, then I want to go get the rate for the vendor. So I'm going to say over here, rate equals, but where is the rate though? Well, remember where the rate is. The rate is available from the third-party service, which means now my class has a vendor one. It needs to make this call to the service and say, hey, service, I'm going to give you vendor one and the currency. Can you please give me the price back? Well, at this point, if you start talking to the real service, maybe a web service of some kind, you got to set up the service, you got to ensure all the security things are passing, you got to get the result, and once you get the result, you're going to say, oops, what do I put in that test? Because I don't know what the result is going to be because the market is fluctuating, and so I don't know what currency is going to be back, right? So that's a problem you're going to deal with. So I'm going to postpone that entirely for now and say, forget it. I don't want to talk to the real service right now. I'm focused on designing my class, which is going to be dealing with that logic. I'm going to mark it out. Now, how do you really mark out a service? In a language that supports dynamic typing, you could just use a class and not worry about types. C# dynamic can come in handy in those places, but ignoring that, we could use the dependency inversion. We could create an interface and we can work with it. So notice what I'm going to do right away. I'm going to go ahead and create for ourselves an interface. Now, one thing if you notice is I'm working backwards in this. I think about what I want, then I define enough of things for me to have that, rather than saying, let me define everything and come here and start using it. So what I'm going to do here is simply say vendor web service dot get rate, and I'm going to send the vendor and the currency given to me. I'm going to send those two as a parameter. Now, what is it going to return? It's going to return a double value. Once it returns a double value, I'm going to say var adjusted rate equals markdown, and the rate is going to be the one I'm going to mark down. So now that we got it, I'm going to return from here new tuple, and the tuple I want to return is going to be the string and double over here, of course, and this is going to be the vendor that we have on our hand and the adjusted rate that we also have on our hand. So this is almost ready, except we don't have a clue what this vendor web service is. We need to define that. So I'm going to go up to the class right here, and I'm going to say, first of all, right here, I'm going to say I vendor web service, service over here, equals, rather, vendor service. So I'm defining that right here, but we need to have an object of that type. Where do I get the object of that type? I'm going to implement the constructor right here, and I'm going to say vendor web service equals the service, where the service is going to be given to us right here as a parameter in the constructor. Well, right now the constructor doesn't have it, so I'm going to say the service equals, and I'm going to say null right now because I don't care if that value doesn't come through at the moment. So that requires us to define this I vendor web service. So where am I going to implement that? I'm going to implement that as an interface, and I'm going to implement that as an interface in the library itself. So I'm going to say this is going to be a public interface, and that's going to be the I vendor web service. We need a method for it to work. So if I go back to the code where I'm using it, you would notice there's a getRate method on it. We'll actually call this as getRate from service, just to distinguish. And what is this method going to be? Let's go ahead and implement that method again in the service. So I just did. So if I go back and look at the interface, you can see that it returns a double. I'm going to change that to a double. And get rate from service, takes a vendor as the first argument, and the second argument is going to be the currency. So that's our interface we define. So I'm defining the interface based on the usage in the code as much as I know so far. Now, where is this interface? The interface is in the same library as the real code is, so that's where it is sitting. So if you notice, my currency exchange is sitting right here, and the vendor service is sitting right next to it. That's where these two guys are residing. So that's great so far. We did that. But of course, this won't work yet, because the test doesn't have any clue about this service at this point. So what am I going to do? I'm going to say currency exchange over here equals, and I'm going to say new currency exchange, but I need to provide for it a mock service, right? So where does the mock service come from, right? That's got to come from somewhere. So I'm going to go ahead and create this mock service. So I'm going to say class mock service, and this is going to extend from iVendor service. And what do I do in here? I'm going to go ahead and override that one method we want to override. So let's go ahead and ask him to implement that interface. So it writes this get rate from service method, and all I'm going to do here is return that fake value 100, right? That's all I care about to make this work. And because my test is expecting a 98 as a result. So let's review what we just did. We wrote a method where, oops, error, let's fix the error before we go any further. I probably forgot a semicolon in some place. So it says it does not exist. Of course, I need to create that object. Oh, okay. So mock service is going to be new and create an object of mock service. That should make that happy. So what did we just do? What I did was we created a currency exchange, passed to it a mock service. We externalize the service into an interface, and our code says, if you give me a reference to an interface or a reference to a service, I will talk to the service, get the result back. The code doesn't know that this is a mock service. That's something important to keep in mind. The test knows about the mock. The real code doesn't know anything about a mock, right? So it says, I'm going to talk to the service. We sent in a mock service in place. And what does the service do? It simply returns a fake 100, and then this is saying, oh, you gave me 100. Let me adjust the amount. That's 98 now as a markdown. Here you go. Here's the response so far. Am I making sense so far? What I'm doing? Questions? Are you happy with what's going on so far? Right? We just externalize the service so we can focus on our code, right? That's all we did. Well, guess what? The test is passing at this point, so we are doing really well at this point. Well, that's great, but problem is in the real world, there are errors when you talk to services. What do? Well, I'm going to write a test for that. So the next test is going to be that we're going to have an error when we talk to a service. So I'm going to go ahead and copy that and say, get rate with one vendor, but run into error, let's say. So what should I do when I run into error? Well, running into error is my problem. The customer doesn't care about me running into an error. So the first thing I'm going to do is return a vendor of empty and a value of 0, because the customer doesn't care that I ran into an error. So that's what I'm going to return when there's an error. But if I run this code this time, you will notice that the test is going to fail. And the reason the test is going to fail is our mock object is returning 100, and as a result, the test says, hey, you expected an empty and a 0, but that's not what was returned. It returned a valid vendor and 98. What's going on? Well, okay, we got to do something about it. So what should we do? Well, here's an idea. We could come back to this little mock and put a little flag in there, right? And we could tell the mock, if the flag is true, quietly return 100. If the flag is false, throw an exception. Have you ever done that before? We have, right? And now what happens? Slowly but surely, the mock is growing just a little bigger, right? And then you write one more test. And that test wants something a little different. So you go to the mock and say, hey, mock, do me a favor. Here's another condition for you. And the mock is getting a little bit more bigger. And over time, what happens? This mock is no longer called a mock. It's called a monster, right? And you feel, and one afternoon, one developer comes to you and says, I got a question for you. Do we need to write unit tests for the mock object? And now you know you've gone in the wrong direction, right? So this is how our test goes to hell when we start writing these mocks like this. So the first rule, a mock should have absolutely no intelligence. A mock should not grow. A mock should be as dumb as you can keep it. All it should do is simply return results. Don't put any logic into it. Well, then what do? The first rule is create a separate mock for every single test. Now, at the first sight of that little idea, you may say, that's crazy. We're going to have so many mocks laying around. Is that even practical? Don't worry about that right now. Let's take the principle a little further. So what we're going to do here is leave that mock alone for a minute, and let's just grab this mock for a second. And I'm going to grab this mock right from here, copy it, come back to right before the second test, paste that right here, and change it to mock error service. That's what I called it. And now I'm going to change this to throw new application exception, and I'm going to say error talking to service, right? So that's all I did. Now we gave a new name for this guy. We called it the mock error service, and I'm going to come back here and change this mock service to mock error service. So go ahead and run the test this time, and the test is going to pass because actually, the code is handling it. We haven't done that yet. So what am I going to do? I'm going to now go to the code, and I'm going to say, go ahead and put a try block around here, and call this method. And if there was an exception along the way, well, just go ahead and say at this point, well, there was an exception, and I'm going to simply put a catch block right here. So let's go ahead and say a catch. And what am I going to do? Catch exception, some exception that I received. And what am I going to do with this? I'm going to just ignore it for now. That's a bad idea, but don't worry about it right now. We'll come back and fix it a little later. So what does it do? If there was an exception, it is simply going to return that tuple with an empty and a 0 value. And if there was no exception, it's going to do the right job. And you can see that the test is now passing. So that seems to be OK so far. So what did we just do? All we did so far was we created a separate mock. Well, that's great so far, except now we landed into one other problem. Now we end up creating one mock per test, potentially more than one mock per test, and now we got all these mocks we have to maintain, and that becomes really expensive. So this is when normally you want to upgrade to a little tool, a library that can help you with mocks. What library do you want to use? Well, take the word mock, and take an arbitrary word and put it either in front of the word or after the word and Google for it. Chances are you'll find a library with that name, right? That's how many mock libraries there are out there. And if you, as you're looking for it, as you're Googling for it, people are creating more mock libraries, right? People just have this fetish to create mock libraries. I don't know why, but there are so many. And pick your poison. Use whichever you like. I don't really care which one you use as long as you put it to really good use. I've used a few in the past. I've used RhinoMock, for example, NMock and stuff like that. They're all fairly good tools. Now I'm going to show you just one tool which is called Fakes, which is available in Microsoft Visual Studio. And Fakes actually came from Molds as a research project. And Fakes has some really interesting features. And I'm going to show you how we can use that here to do what we're doing. You can use any tool. I'm just going to use Fakes over here. So let's remove the burden here of this mocking. So notice what I'm going to do. I'm going to go back to this first test we wrote here. And this is the mock service, remember, we wrote. What does this mock service do? It simply returns 100. I'm going to remove this mock service. Poof, the mock class is gone. So what am I going to do? I come back here to the code where it is mock service, and I say, instead of new mock service, right there, remember this was the mock service we created, and we used it in the code. I got rid of the mock service. So what am I going to do? I'm going to go back here to the test library, and in notice that I have this currency exchange lib, and I'm going to right click on this library, and I'm going to ask him to add the Fakes library right here. So add Fakes library, he is going to bring in the Fakes library. That's what I did just now. Now that I've brought in the fakes library, it requires a little bit of recompilation usually. I'm going to say in here that I want to go ahead and call the currency exchange lib dot. This time notice I'm going to say fakes. So I'm going to say new currency exchange lib dot fakes, and then I'm going to say dot, and I'm going to ask him to bring in a stub for the vendor web service. So I'm going to ask it to create for me a fakes object of a stub for iVendor web service. That's all I did. And once I did that, the next step here is to define the fake behavior. So what is the method? The method is called get rate from service. Remember that method we created on the interface? Well, there's one small problem. .NET supports method overloading. So there could be multiple methods potentially with the same name, and it has to know which one you are interested in overriding or marking, stubbing. So to do that, what they provide is a signature that includes the method parameter types in the signature. So what this means is, it says get rate from service string string. If you had another method that was different signature, that would be not string string, but a different signature based on what the method signature type is. So we say we want to mark that particular method and simply assign it. It's like a property, and you say vendor comma currency. And what do I want to do here? Simply return 100 from this. That is all we did. I'm going to run the test this time and see what it does. Oh, a semicolon. He's not happy with me putting a semicolon. Let's get rid of that. That's just a lambda expression we are providing right there, which is really a nice, sweet syntax. I like this syntax because it conveys the essential idea that we are providing a function as a mark here. So that works really well. So notice I got rid of that function, that class we wrote. But the nice thing about this is, this little mark nicely resides within the test itself. If you remove the test, the mark goes away with it. The mark is nicely contained within the test, gives you the focus of what is needed to make that test pass. This mark was created just for that test, right? Continuing the principle I talked about earlier. Same way, I'm going to go back here and remove the error service from here altogether. And similar to what we did a few minutes ago, I'm going to go back here and say new, and be a custom a currency exchange library fakes over here dot stub. And what is this going to do? This is going to say, similarly, I'm going to go ahead and define a get rate from service string string equals to vendor comma currency. These are the values. And what should I do as a result from here? Well, the result is going to be throw new application exception error talking to the service, right? Whatever you want to specify, you can specify that. Again, run the test, and this is, oh, let me fix that semicolon issue right here. He's not happy with that. So let's go ahead and fix that problem. So in this case, of course, I need a semicolon, so let's go ahead and put that. So what do we do? Again, we created just a test only dealing with that condition within this test, and the test is passing. So all we did so far was we created special marks using the fakes library, and we just did that. Similarly, we could implement two vendors, right? And how do I implement two vendors? I could implement a test where I could pass in a mark again within this test. And what does the test do? It simply sends a request. It starts asking for the mark, the service for vendor name, and I can simply give it back using a dictionary of some sort. I can implement it very easily from within this test itself. So that works very nicely, and we can go back and implement that test. That's not a big deal, right? So I'm going to skip those parts, but let's get to something a little bit more interesting that we can do. So what we saw here was how we can mark away these, but what if the dependency is a little bit more intense than what we just saw? So one nice technique to marking is you take the object you depend on, and you say, look, my code under test is depending on this object. I'm going to create an interface. So I'm going to depend on this interface. This class is going to implement this interface. And when I am doing real code in integration mode, my request is going to use polymorphism and run the real code. But during test times, I'm going to have a mock object running here. So the code again goes through the interface. Polymorphism takes me in the test to the mock rather than the real code. But to do this, we got to do a few extra steps. The first is your code, depending on the real code, now has to depend on an interface. So you have to design it to use an interface. This code that you want to depend on must support that interface also. If it doesn't, what do? You could use an adapter pattern and route the call to an adapter, but that's an extra step you have to take. You got to design for this. And honestly, I would say that's probably a good thing to do in a number of situations. So rather than keeping the dependency, make the dependency go through an interface, this is called loose coupling. And loose coupling is a good design principle. The principle we just followed here in this example is often called as the dependency inversion principle. So rather than depending on the real object, we depend on an interface. So overall, collectively, this is a good design idea. However, there are times when you really don't want to go through that extra step. You say, you know what, great, I understand all these good design principles, and I would follow this most of the time, but this one is an exception. In here, I don't want to go through that overhead, or you have some code already in place, and you want to test that code like a legacy code, and you don't want to refactor the code at the moment to remove the dependency. What I'm going to show you, I want to emphasize, use it very reluctantly. It is a very powerful tool, but remember the wise words of Uncle Ben from Spider-Man, with great power comes greater responsibility. So don't use it so easily. Think several times, and if you really have an urge to use it, go to your colleague and say, hey, I want to use this. Does this really make sense to use here? Get a second opinion before you use it. So you've been warned, you've been cautioned. Don't tell Venkat showed me this, I have to use it. Well, use it very sparingly. But a very powerful tool. Let's understand what that is by writing a test itself. Now, I'm going to make this problem a little bit more complex. Remember the problem that was given to us. When an error happens, we have to log the error. Aha! So if error happens, we got to log it, which means when I have a one vendor which has an error, I have to go ahead and log an error detail. So how do I go about doing this, right? So that is the next thing we want to talk about. How do we go about logging the error? So I'm going to take this example we wrote right now, copy that over, and I'm going to say a log error when, of course, the request fails. So if you notice this example, I'm going to remove this little message here that we sent, and I'm going to say application exception, and I'm going to say instead of error, I'm going to say simulated error, right? That's what I want to say here, simulated error. But I want to log that. How do I do that? So notice, going back here, I don't care about the expected result. Yes, I have the one vendor, that's great. And I don't care about this result, but what do I really care about? Let's start with the result again. So I'm going to say assert R equal, and I want to log it to errors.log file, comma, log file. Well, what is this log file? I'm going to define this log file right here. So let's go ahead and define the log file right here. So I'm going to say string log file equals an empty string. And I want to assert one more detail. What do I want to assert next? I want to say assert R equal, and the message here is error talking to service on, well, when is that? On 4/22/2014, and what time is it? 12:29:00 p.m. For vendor 1, and then I'm going to say simulated error, right? So that is what I want the result to actually be. As thorough as that result I want to see. So what does this say? It says error talking to service and all the message. And what do I want from? I want that from the log message. So what is this log message we are referring to? Well, the log message we are referring to is again going to be a log message string that I want to write as an empty string. And so now we're going to go ahead and call currency exchange.getRate, and this time we're going to get the rate for, again, INR, and ask him to run it. So if you run this code, remember what our code is doing right now. When it catches the error, it simply puts an empty catch block. Remember, that's all we have right now. There's no logging in place at the moment. Let's go ahead and look at the error that we got here for the log error. And if you notice the error for the log error says, hey, you wanted the log file to be errors.log, but it is actually empty. Of course it's empty, right? Because we didn't do any work for it, so it is empty, and we didn't really tell him that he has to do logging. Now, how many times have we found it so easy to write the code, but we have no clue how to write the test? Have you ever had the problem? Guess what? I have the problem too. And I would say I could write this code in 30 seconds, but I have no clue how to write a test case. You know what that means? It generally means we haven't understood what the code really does. And what you do at that point is you stop that urge to write that code and go figure out how the code works. That may take you an hour. That may take 2 hours. Guess what it does to you? It builds strength in you. And the more problems you solve like that, about the 10th time, you have a technique to solve the problem very quickly. So we're not going to write the test. No, we're going to write not write the code. We're going to write the test before we go off to write that code. So what are we going to do here? What we're going to do here is we're going to wrap this into using, and we're going to bring in this thing called shim's context. And shim's context it's like an AOP. It really creates an environment totally around you that creates a situation where the code doesn't have a clue that it's running in this completely marked out environment. So I'm going to go ahead and bring in the necessary library here, the testing tool for it. So we just brought in the shim's context. That's what we did. Now, how does this really work? This is as if, you know how sometimes you do this plot, right? You have a little brother or a sister and you fool them, so you tell all your friends, you know, I'm going to call this person, my brother or sister, tell this, and when they ask you these questions, say these things, so they don't even know that they are in a pretended environment. That's what we are doing. We create a complete environment, a fake environment, where we're going to mark out these things. So notice what we're going to do now. We're going to move this code inside this little environment right here. So grab that into this. And within this code, what we're going to do, first of all, let's take baby steps. The first thing I'm going to do, I kind of know what code I want to write. I want to talk to a file and ask it to write some stuff. So I'm going to go back to the library here. And I'm going to go to system right here. And in the system, I'm going to tell the system right here, right click, and say add fakes assembly. So I added fakes assembly to the system library itself, and I'm going to say system right here. Actually, it's probably a good idea just to recompile that to make sure it compiles and generates a fakes library. So now I'm going to say system.io.fakes over here. .file, but this is going to be a shim for a file. Write all text string equals. That's going to give me a path and a message. And what am I going to do within this code? All I'm going to do within this code simply is say that log file is going to be the path, and I'm going to say log message is going to be the message we obtained. Notice what we just did. So we simply said, I'm going to go ahead and grab this response that comes back and send it out to this. So what is this code really doing? It says when the real code calls the file's write method, quietly come over here, don't do any real work. And when it comes over here, we grab the path and we grab the message and simply store it, and we don't really write to a file. Why is this better? Because if you really write to a file, your unit test is no longer a unit test. You got to worry about reading the file, processing it, and that becomes a burden. We kind of got rid of all of that right now, and we just simply store this away. That's all we just did here. Well, that's great so far. We saved it away. This is not done yet, but that's a good start. Now I'm going to go ahead and run the test. Again, it's going to fail. Why? Because our real code doesn't really write anything to the file yet. We'll take the next baby step. Remember the error we got so far, that the file name was expected to be errors, but it was empty. We'll fix that problem first. So I'm going to go back to the code right now, and in the catch block, I'm going to say system.io, so system.io.file dot write all, and what am I going to write? I'm going to write to errors.text, and what am I going to write? A message I'm going to write. What in the world is the message? Message is going to be blah, right? So we'll come back to that in a minute, right? We'll take baby steps. We'll come back to that. Let's go run the test this time and see what it does. The test should still fail, but I'm hoping it will fail for a different reason this time. Let's go ahead and take a look at what it is doing. Well, actually, in this case, I want to say errors.log, pardon me, errors.log, that's correct. So let's run the test one more time. And this time, it's going to not fail for errors.log because it knows what errors.log is, the file. So let's take a look at what the error says this time and notice the difference. The error this time says, hey, you expected a message to be error talking to service on. Well, this is going to be a variable value. I'm going to remove this part, that is 0, and then for vendor, well, I don't know what the vendor is, so I'm going to remove that as 1, and then the result is going to be whatever the result was. That's going to be 2 and comma, and what's the first value? Well, the first value is the date, so datetime.now. The second value is going to be the vendor, so I'm going to put the vendor. And the third value is going to be error.message, right? Exception.message. Let's go ahead and run the test and see what it tells us this time. Well, when we run the test this time, let's notice what it's going to still fail the test, obviously, but notice the error message is different. The error message now says, well, you expected error talking to service on 4/22/2014, 12:29, but the time is 12:37. And of course, the rest of the details, thankfully, are correct. So, wait a minute, what is the problem? The problem is that the date keeps changing. So, how do we really tell, hey, the date should be whatever the current date is? And I'm sure we all have tried this at some point, right? So, what do? We set the date value, in the test, we find that current time, put that in the message we want to put, and then we go run it. And guess what? It works fine for 3 months. And suddenly one morning, it fails. And I'm like, why did it fail? Well, it's that fateful time between the time you noted the time in the test and the time that the code ran, it was off by 1 second. And you're like, darn it. And then you say, let me run this again and see, right? That is an example of a poorly written test because it passes sometime, fails sometime. You don't want test to be that. But thankfully, we can fix that very easily here. Notice what I'm going to do, by the way. I'm going to go back to this code before we call the method one more time. We use a system dot and fakes dot, and we're going to say shim datetime dot now get equals. I don't pass anything to it. I want it to return a new datetime object. And what is the date I want from here? Well, I want 2014, April 22, and the time I wanted was 12:29 p.m. And so that's the value that I want to send over in this code. So we are asking it to fake it. So now I run this. So what did I just do? I simply faked away the now method, the property rather, the null method on the test itself. That's what we just did. So I go back and run the test, and let's see what the test is going to tell us, assuming that I could write this properly. It's going to be 29 p.m., and that's what I wanted to return. Well, it looks like there's a little bit of a formatting error. Let's take a look at the error here. It tells me that error talking to service on 04. So that's 04 that's coming back, not 4 itself. That was my error, so we can go ahead and fix that right here and say that should be a 4 and not a 04. So we can go ahead and run that again and set the format. So you can see that the time is really the same as we wanted it to be, and that takes care of it right away. And we can make sure the test is passing. And of course, a passing test means you can have uninterrupted sleep in the night, which I really like to have, right? So to me, writing automated tests is extremely important. Like I said, I do this not because I have a lot of time. I do this because I don't have a lot of time. And I care a lot about having automated tests. So I invest my time in writing automated tests to get a meaningful feedback. And one of the biggest things about agile development is what? Is feedback-driven development. And if you don't have that feedback from your code, then it's really hard to respond to change in a dynamic fashion, in a fast fashion. So that's why it's important to improve on these technical skills so we can get that kind of feedback from the code. And so in summary, we can write automated tests. My recommendation is avoid mocking as much as you can because mocking is a burden. So if we can remove mocks, that's the first thing I would do. If I cannot remove the mock, I would do dependency inversion and I would mock out, and the rule of thumb there is keep mocks isolated. Don't make your mocks expensive. Don't make your mocks intelligent. Keep your mock specific to the test cases they are serving. The purpose of the mock is to really enable the test that you are writing to pass by serving the needs of the code that is under test. So keep the focus on that when you write the test. Any questions, comments before we wrap this up? If you don't ask any questions, I would assume you sent your mocks here rather than you being here. So do ask me a question. Yeah, go ahead, please. So good question. A couple of answers, right? Keep in mind that, so I'll read through this with an example. I had somebody come up to me and say, you know what, I upgraded version of the framework and my unit tests are passing. I really hate it. And I said to this person, I'm glad your unit tests are failing. He thought for a minute and said, why are you glad my unit tests are failing? And I said, if the unit tests were not there, what's going to happen? And he thought for a minute and said, I'm glad my unit tests are failing. So keep in mind, that's your feedback mechanism. And yes, you are going to change it, but the cost of that change is so minimal compared to not having the feedback cycle, right? So the net sum is still positive, and then you can devise ways to minimize the problem. How? Don't hard code those values everywhere. Remember the drive principle. Keep that in one isolated place and name it as, format based on config. And if your configuration changes, you got one place to change and not several places to change. So there are ways that we can minimize this burden. But keep in mind, it's like when you have a desire to make something work, you'll find ways to make it better. That's exactly the rule here. My desire is it gives me goodness. And as a result, I'm going to minimize the burden it creates by refactoring code and working through it, because without it, I am worse off. So it's a minor hindrance it causes, but it gives me a greater benefit, and I'm going to work through to find ways to minimize that burden it creates, the hindrance it creates. I don't know the global answer for that, right? Because it depends on the context. But the first thing I start doing is eliminate duplication by defining variable names. I'll change in one place. I was actually pairing with a programmer, and he said, oh my God, I don't like this because if you change this, you've got to change all of this. I said, fair enough, but what's the cost of the change? Very minimum, because it took us about 5 seconds to make the change. And his argument was, oh, but if I'm writing code without test, I would never have to do it. This was a bit of a luck at this point, but I actually showed his own code and suggested one change, and that completely rendered every single code he had worthless. And he had to say, yeah, I guess this problem exists even without tests. So sometimes we kind of think that tests are a burden, but they can actually be a great advantage, and we can ease those hindrances away. One last question. Please. Oh, what script? So the question is there something you can do for PowerShell scripts? The answer is absolutely yes. Because when you're developing PowerShell scripts, you're still writing .NET code, essentially, right? So absolutely. One of the things I've learned over time is it's really a divide and conquer. So we assume a lot of things is not testable, but if you really sit down and say, how do I isolate this code from the dependencies and start writing tests, I can bet you there's plenty of ways to do it. I've been testing on almost any system that's out there, and it's intimidating. Sometimes it takes me 2-3 hours to figure out a solution, but once you do, you got a technique to work with. And actually, I did this for a client. He was writing quite a bit of PowerShell scripts, and we spent about an hour or so figuring out, and we had full unit test on it. So absolutely, the answer is yes, you can do that too. Absolutely. Well, thanks for your time. Appreciate it.
Thank Thank you. Thank you so much, Venkat. And can we give him another round of applause for that great session? Thank you so much.